but we'll get started now. So Joyce isn't here today. She's still on her spring break, so it's just me today. We'll start off by going over what we went through last week. And so if you guys remember, it was building a few new files. The first one was the Docker file. And so just to go over that, if you remember, we start with from Python and then you specify the language we're using. Run is a keyword to run a command. So we're going to run a command to make this directory. And then work directory changes that from the base directory into this user/app directory. Copy is to copy everything from our current directory into this user/app directory. And then we can run pip install -our requirements.txt. If you remember, we don't need to install a virtual environment because the idea is in this Docker file, it'll be running inside a container. And so the container has everything we need. There's no reason to put a virtual environment in there when we can just directly install it onto the entire container. Lastly, the command keyword is similar to the run keyword, but it's used when you actually want to start your app. So command python app.py. So that's the Docker file. Does anyone have any questions about that? All right, next, we also had to create a docker compose.yaml. So to do this was so that we wouldn't have to type in longer commands into our command line. Instead, we could type in docker compose up and docker compose down. So if I do that now, this will have everything I need to just run our app using mapping the port for us, also including the env file, and it takes our image from Docker Hub. And then to quit out of this, it's Command C. So this PA5 is due on Wednesday. I wouldn't really recommend using slip days. It's really just creating these two files and setting up your Docker account. There's a few more files here that we have. If you remember, we have the .docker ignore. And so here's where you include everything you don't want to actually show in your image. So for us, we don't want PyCache because that's local to your machine. We don't need to install a whole virtual environment since we're already going to be installing that into the container anyways. Obviously, we don't want to show our .env file because that's the file that has all our private passwords. Anything that we don't want to be showing to the public will go in that file. And then lastly, we don't want our database showing. So this todo.db that you see, we don't want to actually import that. That's more for testing. So we can put that in our .docker ignore. That when we build our image, that does not get included. To go over how to build an image one more time, it's docker build -t, and the -t is so that you can include a tag. Then you put your username. So if you go to your Docker Hub account, you can figure out what your username is. For me, it's just my net ID. Slash. Wait, so first I want to see what images I have because I've already built some of the images. So Docker images shows you what we have. Then if you see we have version 1 and version 2. If I wanted to make version 3, I could do docker build -t, include my username slash the name of whatever this assignment is or whatever we're building here. So in this case, I might want to make it demo5 and then a semicolon to specify the tag. And so in this case, it'd be version 1.3. And then you do dot at the end to specify where you're building this image from. And so I'm already in this demo5 directory. And now this image will be built. That should be everything from last week. Do you have any questions on anything we learned then? Yeah. Because there were two what back to back? So you can only specify one tag. So if you wanted to include like a longer tag, you just have like different like notation for how you'd want to tag that. So this image obviously finished building. You could then do Docker push. So this is that second line that you need. So this will actually push your image. So we can specify username /PA5 semicolon version 1.3. And this will actually push that to Docker Hub, Docker images. Demo 5, not PA5. And that actually pushed it to Docker Hub. And then from there, you can use that to then build the image on any other computer and then create that container. Next, we can go into the lecture for today. So today we're going to be talking about deployment. The first thing, these are some announcements so that we have, so drop deadline is actually tomorrow, I believe. That's not updated. But if you're going to drop the class, which if you stayed at this point, I hope you guys have done some of the assignments and are planning to stay in. But if you do drop, I think the deadline is tomorrow, but I'll post on Ed just to be sure. Attendance grades, I'm going to be publishing on CMS soon, so you'll be able to see how you're doing. And then PA5 is due on Wednesday. So this was some review. I kind of already talked about this, but you want containerized so you can package code into a standard unit of software, and that can be run on different servers. You're able to build code into images, and that's what we uploaded Docker Hub. Docker Hub is then we can go to a different computer and easily get that image from Docker Hub. And then you run these images in containers, which is like an isolated piece of software, or you can download packages that don't interfere with other packages in different containers. And then you can push those images to Docker Hub so that you can pull them from other computers. So what we'll be learning about today will be servers. And so servers are just a piece of software or hardware that just run your code. And so the idea is that the servers can accept and respond to requests made by clients. If you remember when we went through this on the first lecture, a server can just be another computer, or a server can be some other piece of hardware far away that you're not actually interacting with physically, but you're interacting with over the cloud. And it's just something that you can make requests over using a network. So there's some examples of servers here. You could have like a web server. So this just shows pages and run apps through web browsers. And so this is just like similar to if you had an app.py that just printed hello world, that would just be a web server. You're pinging the web and you get back something on your browser. There's also email servers. So email servers would be in charge of managing and receiving or sending emails. So you can have clients that are like a desktop app or a web browser that pings those email servers. Maybe you want to like subscribe to an email server, and then every month that email server can send out an email. Lastly is like an identity server. And this is used for managing login and security roles. And the reason why this is separate is because usually identity servers are going to have extra security. They really are dependent on user data not being leaked and just being extra secure. So for example, an identity server might be when you're logging into Student Center, you use CU Web Login. That would be an identity server. I'm sure if you use like Duo Push, like that has its own identity server. And so all those security things would be an identity server. Any questions? Okay, so next are servers and their designated network. So first, each internet server is assigned an IP address. So with IP version 4, there are around like 1 billion possible IP addresses. They all have to be unique. And the only one that might be reused would be 127.0.0.1. And that just signifies it's your local host. So if you ever try to ping that, it's just going to be whatever you're running on your local computer. And if someone else tries to ping it, it'll just be their own local computer. But then IP servers on the internet all have to be unique because if two people ping the same server, it should lead you to the same place. So one example of a server might be google.com, which its domain name is google.com. It also has its designated unique IP address. And so to change from the domain names, which are easy for users, like we can just type in google.com. We don't have to remember what its specific IP address is. You have DNS resolvers. And so DNS resolvers change it from that domain name into that unique IP address. So if you remember this slide from lecture 1, we kind of ignored this DNS at that point. But now if we look at it again, we can kind of see what's going on, where we'll look at google.com. It'll ping a server that's a DNS resolver, and they'll tell us what that google.com IP is. And then we can actually look at that IP, and that'll be accessing those Google servers that are going to send a request to us. Does that make sense to everyone? Does anyone have any questions? Okay. So the next part of this lecture is about deployment. And so deployment is how we actually get our app running so that it's constantly up. and then anyone can access it. So if you guys know, so far you've only been able to run an app on your computer, and you can only access it through that local host. So deployment is that actual process of getting it onto the internet so that people can see it and anyone can ping it. So what does our app need? And these are specific for like any app that we would want to run. We want it to always be running. And so this also kind of goes with open to receiving requests at all times. We want to be able to ping our server. We don't want to have a downtime where like, oh, where you have to use our computer for something else. We want it to just always be up so you can ping it whenever. We also need it to be publicly accessible to the web so that if I want to access data like on Instagram, let's say, I can post something, but anyone else can also access Instagram. You don't have to be on like a private network to do this. And then lastly, you need hardware that is managed for us and connected to the cloud. I don't want to have to manually go into my laptop to change something on a server. I want to be able to, from my laptop, edit a server that's running somewhere else, and then I don't have to worry about the hardware or other unnecessary parts that don't really have to do with the app itself. And so what's really common is to be able to rent a server. And so renting a server is a way to easily get your server up and running, and then you don't have to always have your computer on or always have like your own server going. It's easy so that you can run your application on a server in the cloud so that you don't actually have to have that hardware in person with you. You can also containerize the software the same way you would do on your personal laptop, and we can just do that from our laptop but on someone else's server. And then lastly, it allows you the server to be managed by a cloud service. And so then this allows for things like handling physical maintenance to be done by somebody else. And also you can get tools from certain services, such as automating security, scaling, or automating what happens when it crashes. So if your server crashes, you know how on your computer you need to Command C or like rerun the app. So a lot of times these cloud services will provide tools that it'll automatically rerun the app for you if it crashes, or have other tools to help you in those cases. Does anyone have any questions so far? Okay, so if you look here, we have some popular cloud services. You guys might be familiar with some of these. So Amazon Web Services or AWS. DigitalOcean is what we use on app dev. Microsoft Azure is also a popular one. And then what we'll be using for the course is Google Cloud. So now how do we actually access these servers? Because obviously we want to be able to deploy our app on these servers, but we don't actually have physical access. And so to get access through the cloud, we have to use what is called SSH. And so this is a secure shell network protocol. And the reason why this needs to be super secure is because obviously this is where you're going to be running your app. And if you imagine it's much like your computer, where you might have like a data table of a bunch of users' information, and this cannot be leaked. It needs to be highly secure so that other users can't figure out a way to get access to this. And we'll go more into the security of this a little bit later. But this gives users a secure way to access a computer. You can then open and view resources like files. You can also execute commands from your command line. And then you can install packages and update software from that command line as well. So this is what it might look like to SSH into a server. This is the Eatery backend server. So I'm working on Eatery backend this semester. If I actually need to go into the server and change the server, maybe I want to update some packages or update the code base itself, I would type in this command at the top, SSH-I. The -I specifies that I'll be attaching a file. Server.pem is that file. And then the user, so appdev, and then the server name. So server.pem, a .pem is just like a security file for SSH. And that is just going to be what's read so that the SSH knows that I have a user that has access to this, to access this. And then appdev, the user is just like whatever user you want to use in case you're going to be like modifying data and you want to have tracks of like what users actually being the one modifying. If you have many different people accessing the server, and then the server name, it just depends on whatever you're calling it. For us, it's eatery-backend.cornellappdev.com. Oh, one more thing to point out is if you see at the top, it says .s/eatery. So that might just be the folder I'm in on my local computer. But then if you look at the bottom here, it changes to appdev@eatery. And so this specifies that you're actually SSH'd into a server. You're not changing files on your computer anymore. You're changing files on wherever that server is. So if you install any package and then you leave this SSH or you like close out of your terminal, you're not going to actually have those packages on your computer. But the server that you're SSHing into will now have those packages. Does that make sense to everyone? Okay. So we'll go back to security real quick. So a lot of times security is just providing a username and password credentials, but this is not that secure because passwords can be cracked. With enough tries, you can usually guess most passwords, and it might just take longer just because your password is longer. But that doesn't necessarily mean that you'll never be able to guess the password. So trying to instead make a public key pair is a way to make some more secure connections. And so you do this by authenticating a local to a remote and then a remote to a local. And so what this looks like is you have this key on your computer as well as a key on the server, and they both need to coincide in order for you to log in. So for example, when I SSH into this user@server.com, so it's just like an example, I'm a user and the server is just server.com, and you'll be prompted with the server's key and a request to connect. So if you've never connected before, what'll happen when you put in that SSH, like that PEM file, it'll add your computer to, or your computer will add that server into known hosts. And this will allow you to SSH quicker in the future. But that first time, you really need that extra layer of security to make sure that people that are accessing server really should be accessing that server. And so these public and private keys are usually like very long encrypted strings. So now GitHub no longer allows you to change a lot of public repositories with just a username and password because it's not as secure. Instead, you need to use these SSH keys, which are those long encrypted strings that are much harder to crack. So once you SSH in, if you're successful, it'll open up that command prompt. And from that command prompt, you can then look at the resources or update files or change whatever you need to change on the server. So next, we're going to be talking about how to integrate Docker with Google. And so this is how you can actually build an image on your laptop, push that image to Docker Hub, SSH into the server on Google's computers, and then download that image and run that image. So the steps are to, well, first, so Google is a cloud service, and it allows you to deploy these Docker images easily. You can build, push, and release images to the web as well as running them on that server. So once we get these servers up and we have our app deployed, what are possible ways for us to optimize these servers? So the first one is by clustering. And clustering is a technique where you have groups of servers, but they connect as one system. And so each server is optimized for a particular purpose, and it allows for better performing systems. So this is an example. If we have a server and we want to cluster our applications into a web application, a file storage system, and then a database. That way the server can communicate with each of these separately. And if our web application has certain packages we need to install, we don't need to install that as well for the file storage. The file storage can just have its own packages, as well as a database containing only what it needs for that database. So this is one optimization we can do to help improve. But what happens if that server crashes? Well, we can usually have many servers. And so now you can have 3 servers, each of them connecting to each of these applications. If one server crashes, you can still go through another server and still get what you need. And the other nice thing is that what it would be a drawback from having this clustering is that if something crashes, you then need to figure out which one of these actually crashed, because if it's your file storage that crashed, you wouldn't know whether it's the web app or the database or the file storage until you actually go into each one and see exactly what's going on. You'll just know that your app as a whole isn't working. So you want to have many servers, and then clustering helps the bottom part of this slide here, but also has that one drawback. Of course, the drawback to having many servers would just be the cost of having many servers running your app at the same time. So these are some of the benefits. You can have backups and you can crash handle by having those many servers going. The backups would just be having the many different applications. So you could have many with the same thing. Systems management, you could have, like we have shown here, if someone is in charge of the web app, then they don't really have to see what's going on with the file storage, and they can just worry about the web app. Same with the database. If you have like a database engineer, they don't need to have access to everything. They can just have access to that database. And then scalability and load balancing. And we'll go into what load balancing is right now. So load balancing is something, it's like its own little server that all it does is it looks at all the incoming requests and then maybe sends it to different servers running your app. So if you get a lot of requests, you actually want to, and you have many servers available, you might as well use all the servers so that none are like waiting idly. So then you can route each of those requests to different servers so that users are able to access the data as quick as possible. Okay, does anyone have any questions about clustering or load balancing? Okay, so that's everything for the lecture. We're gonna go over a quick demo. So I made an ed post earlier today. Let me find it. So right here, I have a link so you guys can all get free Google Cloud credit. So this was given to us by Professor Walker, and this allows you to all Google accounts will have their own like free trial. But if you use this, you don't have to use that free trial. So if in the future, if you want to use your free trial for an actual app that you're building and you want that cloud credit, you can still do that. And this gives you about like $30 of just like free credit for us to deploy our app. So if you go through those steps, you can get that. And then you can go to this page on the courses. If you just go to deployment and click on demo, you can navigate to this Google Cloud site. And then I'll show you how to actually create a virtual machine where we'll be running our app from. So I'll give you guys a second. You would need to redeem the Google Cloud credits first. Then again, it's the textbook. You'd go to deployment, click on demo, and then we have a link to Google Cloud right here. So I already redeemed my credits. You should redeem it on your school account. So your @Cornell account. I can then switch here and then I can it's not signed in.
Okay.
Yeah.
When I try to sign in, it says that I don't have access to Google developers, Google Coin. We're not gonna use this area as well.
Okay, I'll reach out to Professor Walker and then I'll send out an announcement on Edge so that you guys can all get that before Wednesday when you guys are going to start the next demo. I don't know why I'm not able to log into um my Cornell account here. It just like signs me out immediately. We might have to wait to go over this um till Wednesday if I can't actually do this. Oops. Okay, I got it. Yeah, I'll send out an announcement on Ed um with how to fix the issue to actually get the credits. But you can just follow along. I'll obviously post this to YouTube and then you guys can like follow along to see how to actually deploy or how to create the virtual machine. And then we're also going to go over it on Wednesday. So the first steps to creating a virtual machine, first we have to create this VPC network. This used to be done for us, but now you have to create your own. So to do this, we're first gonna have to create a project. We can just call it demo 6 network, demo 6-network. You do want it to be your organization as being cornell.edu and location as cornell.edu. The setup for this should be the same for all of us. It's pretty simple. So I'll just walk through the steps to set up the network and then set up the virtual machine. So the first thing you're going to need to do when you go on the site is enable this compute engine API. From them, I'm on this demo 6 network. I need to go to Okay, so it takes a second to enable it, but you just have to wait for it to be done before you can navigate away from this. Okay. So now that's ready to go. You can just click create VPC network and then just follow these steps. So this could just be demo 6 network. You don't need to change most of these. You can change the subnet creation to be automatic. And then you just want to allow SSH. Then you can create this network. We're going to wait for this network to be created, and then we're going to use this network that we created to then link that to our virtual machine. Okay, now that that's done, we're going to go back to this navigation menu, and we're going to we're going to go to this compute engine and go to the top where it says virtual machine instances. And then here we want to create a virtual machine instance. So if you remember, a virtual machine is just like another, it's like its own code where you can run your app. It's separate from like everything else that's going on your computer, and it's just somewhere, it's running somewhere else. From here we can name it. So we can name it. Okay. We can name it demo 6 -VM. For the region, you normally just want to pick the region closest to you. It's also not that important. We're just going to go with North Virginia. Here you can pick how much like memory you actually want your machine to have. Regardless, you should be able to run your virtual machine for some time, for like many months, so you don't really have to worry using this Google Cloud credit. We could just do small. We could honestly do micro, but just to be safe, we'll just allow the virtual machine to have 2 gigabytes of memory. Obviously, if you see the pricing is different for how much memory you have, so you're kind of just paying for memory. Then if we keep going down, we're going to want to change this boot disk. So the reason for this is it defaults to Debian, but we really want to use Ubuntu. Ubuntu is very common in the industry. It's also easy to set up on Windows, and it's used on AppDev. So this is just an easy switch to Ubuntu. And then if we scroll down more, we want to allow HTTP traffic. And so normally HTTP traffic, the reason it's defaulted to off is that HTTP is usually not that secure. HTTPS is a little bit more secure, but then still, we just want to use this for our app, and so that front end doesn't have trouble connecting to us. HTTP is the easy way to go, and HTTPS would require like additional setup that we don't really need to go through for this class. Lastly, you're going to go to advanced options. You're going to click on networking, and then it should show that you have this network interface. You want to pick it should default to your network and your subnetwork, but if it doesn't, you're just going to want to pick the one you created earlier. And if you scroll all the way down, you can just create this virtual machine. It'll take a second for this to get created. But then on Wednesday's demo, we'll actually go through how to actually SSH into this virtual machine, then get that image running, and then what it looks like to be able to hit this endpoint from any computer and have your app be like actually like online so that anyone can access it. Does anyone have any questions? There's a little bit of a shorter class today. This is really all I needed to get through. If you guys have any questions about PA5 as well, I guess we're done with this. Now that the VM is done, you'll be able to SSH into it, but we're going to go over that on Wednesday.